So now we're going to start with something called as air distribution system. So in that, first is the we'll have a discussion on the components of air distribution. So first and foremost thing is when your equipment is there, near the equipment at the mouth of the equipment, like axial fans, ductable split ACs, ductable packaged ACs, anywhere which is connected or AHUs as well, whichever is connecting to the duct, that location we will introduce something called as canvas connection because the unit will have motors that will vibrate for sure. And the blower fan, obviously, when it hits the fan, it will vibrate as well. So that vibration should not be transmitted to our ducting, isn't it? So for that reason, we have something called as canvas connection. That at the mouth of every equipment, you have to install this canvas connection. Understood? So that even one end, if it vibrates also, that vibration will not be transmitted to your entire ducting. Clear? At few locations, we'll even provide a zip connection to this particular canvas so that you can measure the airflow if you require at intermediate levels. Understood? So that is nothing but your canvas connection. Then coming to the next one is duct classification. So we will understand about ducting today. So in duct classification, you have types of ducts according to the airflow type, according to the shapes, according to the material, and according to velocities. So, airflow type is again that's again a vague concept where it will try to, airflow type in the sense like a turbulent flow, all those things. For that, it doesn't make a difference for us shape wise because at the end of the day, rectangular ducting shapes are really important, but not the airflow type. Okay, because there are two types. One is laminar flow and other is turbulent flow. Your ducting as such doesn't make a difference, but air distribution makes a difference. So that will I'll teach you during air conditioning concepts while explaining clean room projects. Okay. The next one is the shapes. So according to shapes, we've got rectangular, circular, and elliptical ducts. So rectangular ducts are obviously these are the GA rectangular ducts that we have it. So width and height is different. Square also comes under our rectangular duct anyway. Okay. So for this, the rules of these are quite important. According to your duct size, the sheet thickness will change. Because if you use bigger duct, a larger width duct of very small thickness, whenever the fan switches on or whenever the fan switches off, the duct will act like a balloon. So you'll get the thuk thuk, करके you'll get that sound, number one. Number two, even the duct will tend to sag in between. Understood? So for that reason, it's mandatory to follow certain guidelines. So we will use this particular guidelines at least like in Indian industry continuously, or even SMATNA norms also. But SMATNA even introduced 26 gauge, but we don't recommend 26 gauge above whose thickness is lesser than 0.63 mm. Okay. So for galvanized iron sheet, up to 30 inches, you have to use 24 gauge. 30 to 60 inches, you have to use 22 gauge. 60 to 90 inches, 61 to 90 inches, you'll go for 20 gauge. And above that, you'll always go for 18 gauge. And those are the thicknesses that's available on the right hand side, which is your 24 gauge is 0.63, 22 gauge is 0.8 mm, and this is mm of the mm in thickness. 20 gauge is 1 mm, and 18 gauge is 1.2 mm. Am I clear? So whenever you 99%, or I wouldn't say 99%, but 90% of the time we will use your rectangular ducting only. Because the rectangular ducting means you can play around width and height. So same airflow rate, if the duct height is lesser available, what we'll do is we'll make sure our duct is we will increase the width and we'll reduce the height so that our effective area will remain same. Am I clear?
Yeah.
So this ducts and all we use sizes, no? Duct size and the GA sheet. That's really important for us. While preparation of BUQ or even selection of material. And also gauges as well. You make a note of it once. It's quite important. Also, uh, if you've completed, so there's a concept called as aspect ratio. Okay. So, what do you mean by aspect ratio is nothing but the ratio between width and height is nothing but your aspect ratio. Not the length, it's only the width or height, the cross-section area of a duct. Okay. So when you take the aspect ratio, we'll always try to maintain the aspect ratio not worse than 1:4. It's better you use lesser, sorry, I might have opened new one itself. Take it out. So we will always try to use, sorry, I will create a new project. Yeah. So we always try to maintain a aspect ratio. So what do you mean by aspect ratio is, for example, the dimension is, let's say, for example, 1000 mm by 400 mm or 500 mm. So what is the width that is available? 1000 mm. Just a second, modify it by 150 mm, 150. Textual cell. Okay, set close. So what is the depth of this one? So this is 1000 mm and this is around 500 mm. So here the width is 1000 and the height is 500. So what is the aspect ratio is nothing but your smaller depth by larger depth. So what is the smaller depth? 500 by 1000. So that is nothing but 1:2 or not?
Yeah. Yeah.
So that is nothing but your aspect ratio. That ratio should not cross 1:4 ever. Understood? If it's more than that, you have to consider second act. The reason why you have to use this, it's not economical. At the same time, your gauges also will increase. For example, I'll just give an example, just for two things. One thing is that one, and second thing is if you increase your aspect ratio, your perimeter will also increase, which will result in a resultant larger area requirement as well. See, whenever a fluid flow through a pipe or something, let's say this is a pipe, okay? So do you think the fluid will continuously flow through the pipe or duct with a uniform velocity? Will the velocity of the fluid will be
No, no, no.
uniform through
No,
the section?
no, no.
So where will it be max?
At the center.
In At the center, yes. So you have learned about boundary layer theory in your college, right? Or during engineering.
Mm.
So what will happen at the boundary? The viscosity of the friction will cause the fluid velocity will be lesser at the peripheral.
Okay.
Only at the central
Mm.
portion you have different velocity. You have a higher velocity. So
Mm.
let's say you have one duct with this 1000 by 500. So 1000 into 500 is how much? 1 point, sorry, 1000 into zero point 0.5 is zero point 0.5 alva. 1 into zero point 0.5, zero point 0.5 square
Mm.
meters. You agree?
Mm. Mm.
But let's say my height of the duct is only 250 now. So zero point 0.5 divided by 0.25. If you take it, how much it will be? It will be 2 meters. So
Mm.
dimensions 2000 by 250. Let's say you've got one duct like this. Now, for example, in this case, if you take it, what is the perimeter? 3000 mm. You agree?
Mm.
But whereas this one, if you take it, area will be same, but instead of 3000, it is 4500 perimeter. So now don't you think, which means your surface contact is increasing or not?
Yes, yes.
So that will result in lesser air volume because you're increasing the surface area. That means more volume of air will be going with lesser velocity because it will be touching that particular surface. You agree or not? So
Mm.
for
Yes.
that reason, you have to avoid higher aspect ratios. More than 1:4, you will go, you will have that disadvantage. Second disadvantage is material consumption as well. For example, for example, let's say you've got 1 meter length of duct. Okay, the duct length is 1 meter. Uh, uh, So this is I'm using laptop, iPad. It will be easier, but recording isn't happening. But anyway, slides are also there. So this is, let's say the duct length is 1 meter. We have got it. Okay, I'm just giving an example. You've got a duct length of 1 meter here. So what will be the surface area of this duct? Can you guess? I gave you the width, I gave you the height, I gave you the length. What will be the surface area of this duct?
Mm, mm.
How will you calculate?
Usually
Hmm?
perimeter into length.
Yes. So what is the value? So 1,000. So we'll just do a basic calculation over here. I'll just HVAC measure. So I'll take width, I'll take height, okay, and then I'll take the length as well. Sorry, length as well. So what is the width? 1,000. So I'm bringing in meters. It will be east. So zero point 0.5. So height is zero point 0.5 meters. So length is how much? Length is also 1 meter. I've told you. Then surface area. So surface area is equal to 2L into W plus H or not? 2 into W plus H into length.
Mm.
2 into L into W plus H, width plus height. You agree? So you will get 3 square
Mm.
meters. Let's take someone is trying to enter the meeting. Just a second. I guess Mohammed have also joined. Hmm. Oh, there's no one is up. करके got this thing. Done. So this one, and now let's do the second one. So what is second option is, let's say 2 meters, 0.25, 1 meter. Now, if you do, don't you think your area is 4.5? So don't you think you will consume more duct material or not?
Mm.
Yes. So you
Yes, yes.
almost have like, minus this one if you do it. So 1.5 square meters, which you're wasting your ducting material, which doesn't have any use. For that reason, we always try to maintain your economic. And one thing is, if you increase more than 1:4, your sagging will also increase. Because when you have a duct, something like this, then what will happen when the length is lesser and this depth is lesser and the length is larger, duct will tend to become something like this. Don't you think
Buckling.
so? Yeah, this buckling will also
Mm.
happen. So for that reasons, we'll try to avoid this buckling and all. We'll basically try to maintain aspect ratio not worse than 1:4. You always try to maintain how much ever less is possible. Yeah, 1:1 is obviously ideal, but it's not possible because of the physical constraints like your bottom of the beam and bottom of the fall seating differences. But anyway, we'll always try to maintain aspect ratio of lesser than 1:2. I mean, better than 1:4, like 1:3, 1:2, 1:1. Those things are better. Clear? So while designing your duct, you should always maintain an aspect ratio lesser than that. Clear? Okay, duct sizing I'll be teaching you again. Don't worry. So this is just the theory class. So I'll be explaining about duct theory later on. Then coming to the next one is about circular duct. So when you take your circular duct, there is no option of having aspect ratios because obviously at the end of the day, circular duct means it's only the diameter that you have it. So this is as per SMACNA norms, this is what we'll use it. Up to 8 inches, you can go for 26 gauge. 8 to 20 inches, it will be 24 gauge. 21 to 30, 22 gauge. 31 to 90, 20 gauge. And 91 and above, you'll have to consider 18 gauge. Understood or not? So these are the gauges that we have to use it for the circular duct. But again, 10% of the time, not even 10%, say probably 3 or 4% of the time you will use this circular ducts in projects. Because the main disadvantage of circular ducts is you can't play around with the height. Understood? So because of the height constraints, you might not be able to use this circular duct unless you have double height areas. You can't. And circular duct, to the one thing is it's expensive as well. The reason the first and foremost thing is area, fabrication is kind of tough. So, but it'll take a lot of time. I mean, not every fabricator does that, and they even charge you additional as well. So, for that reason, generally we don't use circular ducts. Okay, unless you want it aesthetically to be something like that. Yeah, general preference will be
Okay.
our rectangular ducts.
Mm.
Okay, so circular duct is simple. But again, if you want to calculate the surface area of the circular duct, it's simple. Your area, your perimeter into length. That is the thing, but your 2 pi r L. That gives you your circular duct or pi dl, whatever. And then coming to the next one that we have is something called as elliptical duct. So this elliptical duct is nothing but this is what we use it whenever there is some exposed ceilings. That means in many cases nowadays, if you go for any tech, any software companies like Google, Facebook, and all, they've removed the entire concept of false ceiling. So instead, now we design entire thing without the false ceiling, so that everything will be exposed, and you will use some kind of dark colors to get it a rustic feeler in it. So in those cases, we'll go for elliptical ducting rather than rectangular ducting if they have some budget. The reason is this will look much better than rectangular ducting if it is exposed. Understood? So exposed does look very good. That's the reason we generally use this kind of ducting, which we call it as exposed ducting, sorry, which is called as elliptical ducting. Yeah. And this is also spiral elliptical ducting, we call it as because you have this kind of spiral, because when the sheet is made, they made this kind of spiral shape over it. Yeah.
Mm.
Mm. Understood. So this is a spiral ducting, and please make a note of the duct fittings, what are the gauges that we have to use as well. Up to 24 is 20 gauge. Up to 36 is also
Mm.
20 gauge. Then it will be 18 gauges. Spiral duct, that is for duct fittings, like your elbows, collars, and all. Normally, up to 24 inches is 24 gauge, 24 to 36 is 22 gauge, 37 to 48 is 22 as well. But your duct fitting thickness will vary. Duct fittings is like your collars, reducers, elbows, those materials. Understood? But whereas for rectangular duct,
Mm.
duct fitting thickness also will almost keep it same. Yeah.
Yeah.
Okay. Then coming to the next one is what are the types of ducting according to the material? So we have got something called as GI or GSS, galvanized iron, we call it as a galvanized stainless sheet steel sorry, galvanized steel sheet is what we call it as. So galvanization process will be taken care by the sheet so that it doesn't get rusted. Okay. Then coming to stainless steel. So stainless steel ducts, we use it only in clean room projects only because it's quite expensive, but you don't want any contamination or you because GI at some joints or anything, it could be rusted, right? If the GI coating is not done properly. So there is a chance of rust that's coming. And second thing is it's not that resistant to acids or anything. Slight acidic environment also, the GA coating will go off. So in areas like manufacturers where there is some kind of fumes, slight acid thing or anything, or second thing in healthcare industries where the rust or the iron in it could basically cause any allergic reaction to any people. So for operation theaters, those kind of cases, we always go for SS, stainless steel. Am I clear?
Mm.
Then we use aluminum as well. So either stainless steel or aluminum, we can use it. But again, what do we do is generally for ducting, we'll go for aluminum. Plenums and all, because the strength-wise, the stainless steel will have a better thing. So we'll go for plenums and all, we go for stainless steel. Ducts and all, we go for aluminum in clean room projects. Understood? Then we have something called as fabric duct, but again, this usage is way less. I mean, till now in my experience, of say 15 years, I have used only two times as a fabric duct. I didn't use much. Two things is the fabric duct will be kind of a circular shape only. Only thing is it will be hanged like a flag, and it will have small pores through the system. Through the, I'll just show you the fabric duct. Then I guess explanation will be better. Just say that. So this is how you'll have the fabric duct. Understood? You can see some image
Mm.
on this one. Yes. So you have something called as fabric duct. So this fabric duct is nothing but this particular fabric duct is like suspended from the slab. So when you suspend it from the slab, basically what will happen is it'll it'll be like a balloon. Okay. So this duct will be something like a balloon. AHU is off again, it'll almost like a flag, it will sag. But only problem is if you have rod ends or anything, that will kind of eat away. Number one, I mean, obviously your rod ends or anything can make punctures to it, right? So in the long run, it's not a solution. Number one. Number two is for uniform distribution only you can use it. And that's also if it's straight. If you have bends or anything, again, this kind of system is served, and your static pressure also will be higher. So you have to waste a lot of energy as well for your fan. Am I clear?
Mm.
Especially if you
Mm.
have bends or anything. So for that reason, we don't use it we use it in kind of open ceiling areas where you wanted to have a feel of this kind of, but that's what, as I told you, the usage is damn less. We don't use it. Let's say, yeah.
Mm.
Hello. Yeah. Then you
Yeah.
have something called as foam ducts or PU ducts or pre-insulated ducts. So that particular duct is made of insulation sheet directly. So I'll just show you that. But that's not environmental friendly. Even that also we don't use it much. Uh, PU ducts. Yeah, like this it will be. So you have this particular one something like this. Arrange all the images so that when I share you this PPT, that is also visible. Okay, so this particular one is made of these sheets. If you can see it in the right corner, there is some kind of sheet. So you directly make it with this particular sheet. But the main disadvantage of this is GIs, you can always scrap it off. You can recycle it. But this PU, you can't recycle it as well. So because of that, this is like an environmentally more wastage that you're creating. Because at the end of the day, after if not 1 year, after 10 years, at least don't you think you should discard that or not? Because you will
Mm.
change the premises or you will change your room design. So in those cases, your PU duct is not useful, but the main advantage is it's quick to fabricate at site itself. We will cut the pieces there and we'll fabricate it, number one. Number two, the weight of this is lesser than your GI, which will cause your structural load. It need not require much, but in which least of a concern because duct light itself is also kind of less. But the third thing that you have it is basically doesn't require an additional insulation like thermal, because normal ducting you have to go for additional thermal insulation. You don't want any wastage of your cooling. But whereas in this case, the duct is already insulated. That will basically result in your saving of insulation working again at site. So time wise this is better, but environmental I wouldn't prefer this one at all. Am I clear?
Yeah.
Of course, we do thermal insulation. That is not environmentally very conductive, but not as bad as PU. So that's a reason. Yeah.
Yeah.
Okay. Now coming to, okay, I guess in previous cases, so this is your pre-insulated duct. This is how you basically make a pre-insulated duct site. So you'll cut the sheet and you try to do it. Okay, I've given this images. So this is your fabric duct. And then we have got the last one, that is your flexible duct. So this flexible duct, we use it in day-to-day, projects where from rigid duct, when we want to connect to an air terminal, see, your design is never constant. What I meant to say, design is not constant is, for example, false ceiling. Architect will provide some false ceiling layout where exactly your 2 by 2 grid or your gypsum, wherever it's coming. Can you give a guarantee that exactly at that location installation will also happen?
No, no.
It can move plus or minus, right? See, one grid tile, start grid tile, if you change it, obviously the rest all will change. So for that reason, if we do it initially, again, you have to rework on the colors and all. So instead, what we'll do, we'll go for this flexible duct. So how do we do it is simple. Just a sec, guys. Sorry. Just a second. Okay. Yeah, I'm audible.
Yeah.
Hello. Yeah. So what do we
Yeah.
do is basically, so from this duct, we'll take a small circular duct. Okay. We'll take a small circular duct. I'll just show you this. We'll take a small circular duct. It's we basically call it as a collar. So we'll take a small circular duct. Okay. Like a tap off, we take it to this rectangular duct. Okay. And to that, we will have a flexible connection, and then we connect it to one more box, which we call it as mixing box. Understood? We connect to one more box called as a mixing box. Just a second. Okay. So basically, you will have one more spout like this, and then you connect from here to here using a flexible duct. Understood? Using a spline or something, I'll just represent it. So using a flexible duct, you will connect to this mixing box. So side, you will provide a similar tapping like this. To that, you will basically connect. In the bottom of this will be open, to which you will connect your diffuser or grill or anything. So air from here, this duct will basically enter through this flexible duct, it will enter into this particular one. So that if this design stage, if this could be moved plus or minus also, do you think this flexible is possible or not? So you have that flexible, you have that fluidity in the design. That's the reason you basically use your flexible duct. So whenever we do it, your main ducting from the main duct, basically you use a flexible duct to connect your, olden days we used to go for collars, but now instead of collars we always go for this flexible ducts. Am I clear? And we provide some kind of damper here so that we can even control the volume of air. We can do air is this. We can even control the air properly for that reason. Understood? Yeah. So this is a use of your flexible ducts. Then coming to the next one is your what are the duct fittings that you have? So one is your straight duct. Next one is your reducer. So when you have to change the duct, I mean, like in the ducting system, what are the components that we use basically? Okay. In the total design, we'll use all these components majorly. Okay. So first one is straight duct. We use it, and the second one is we use your reducer. I mean, when you wanted to change from, say, for example, some volume of air you have already delivered. So remaining volume of air you want to take it further. So obviously you need not use bigger duct, right? Don't you think you can reduce the duct size because you have already pumped some air out or not?
Yeah.
So for that, we'll go for reducer. And then you've got whenever you have to take right angle or anything, you have to go for elbow. When you want to collect multiple ducts into a single one, multiple units into a single one, then you use a plenum. I'll explain you about plenum, don't worry. Then you use droppers. That means from the duct directly, if you want to push the air out, you will go for dropper. It can be even for rectangular as well. And then you'll use collars. If you want to throw it from the side or anything, you'll use collars. Of course, bottom also you can call it as a collar. So in fact, a dropper is also one kind of collar, I can say it. And then whenever there is some height changes in the ducting because of the beams or anything, you have to go for this offset piece. Then if you want to distribute the air, some volume of the air should go front and some volume of the air towards the right or deviation you have to take it. Then you have to use something trouser piece. There is two-way trouser piece, three-way trouser piece like that you have. And the next one that you have is basically your transition piece. That means you wanted to connect from rectangular to circular. Let's say you have inline fans, which has a mouth of circle, but your ducting is rectangular. Now you have to connect these two. So obviously you should have some change transformation in the shape, right? So that is nothing but your transition piece. What is this called as? Transition
Transition.
piece. Understood?
Transition.
And then you have dummy that will be at the end point of your entire ducting. It's a simple rectangular sheet, nothing else. Understood? So
Mm.
now I'll just show you which all locations will have this particular type of systems. Is that fine? Let's say,
Mm.
I'll just give an example in this case. Let's say this is our room that we have it. Okay. This is a room that we have it over here. And these are two more rooms. I'm just giving an example, that's it. Okay. So I'm not doing it with dimensions and all, so don't worry. I'll make a 30 by 40 or something. Uh, 10 meters by 8,000, 10,000 by 6,000. Okay, 10 meters by 6 meters room, let's say I've got it. And let's say I've got one more room over here. Okay, I've got one more room at this particular location where I have to throw air into this particular space. Now, let's say I have two units in this. Let's say this room is critical room where I have to do air conditioning 24 bar 7. Okay, let's say I have to do air conditioning 24 by 7. So when I have 24 by 7, don't you think I should have two equipment so that if one fails, at least other one will come as a backup? And obviously, I don't want to run a unit for continuously 24 hours, right? It should get some rest. You agree? Or the motor will burn quickly. Yes or no?
Mm. Mm.
So for that reason, what do we do is we have to use two different units. Let's say I can't use high volume units or anything because of the volume, and I wanted to use ductable split ACs. Can I have two ductable units with two ducting?
No, no, no.
Option number one, or can I have a single ducting? Because obviously the duct is a non-movement part, it doesn't have any repairs once you install it. So because if air is flowing or not, it doesn't make any impact on ducting. So one ducting which is having common to both the equipments, which is better or economical for us.
Second.
Second option. So obviously it's better. We have two units connected to a common plenum, and from there we'll connect it. So let's say this is a small. I should have some standard blocks. Just a second. Data. Design jobs, standard blocks. I should have some AHU. I mean, we've already made for polish. Let's say, let's take this guy. See, 0.6. Let's say I've got two such equipments. Okay, I've got two such equipment. So let's say this is one equipment, and this is also one equipment. Now, don't you think I should have some kind of common plenum so that when the air is flowing through that, I'll have a plenum to connect and then have a common ducting or not? So let's say I
Mm.
have got a plenum connection. So I'll just draw it with other color. Oh, this is not visible, Alva. I'll make it with yellow.
Mm.
So we have a common plenum to this. And this boxing, we call it as plenum, which is collecting from both the equipments. And then we use one duct to get connected like this. Yes or no? So let's say I've got certain air that I'm throwing it over here. So let's say this is open space, so I don't require any collars. I need not require any. Let's say this is open ducting, but let's say like a UPS room or anything where no one really gives a damn about aesthetics. So I need not even have my I need not even have my fall cell. So if it is no false ceiling is there, I need not throw air only to the bottom. I can even give side throws as well. So for that reason, I'm giving a column, let's say. Dimensions and all, don't worry. I'll teach you sizing later. This is just for explaining all the components. That's it. So this piece, we call it as collar. Okay, so whenever you observe a collar, there will be one more component that is an additional compared to this size. So compared to this size, there will be some additional protection, which we call it as shoe piece. Understood? What do you call it as?
Shoe piece.
Okay, the reason why you call it a shoe piece is simple. The reason why you have to install shoe, can you guess the reason of shoe piece? If the airflow direction is like this, in the same direction, it should always be parallel to the airflow direction. Can you guess why do I want this particular shoe piece? Yeah. So
No, no.
this duct won't be there over here. I mean, you'll cut the duct and you'll connect it. Obviously, then air will be going through this. Yeah. So why do you call it as a shoe piece? I mean, why do you
To
have,
reduce
I mean,
friction.
not call a shoe piece? That's a stupid question, I know. Why do you provide that shoe piece? Sorry, reiterate my question. Okay. Let me just explain you. So you will always you do your collar size according to your volume of air required. Understood? For example, let's say this duct has, I'm just give random examples, that's all. Okay. 500 or something, let's say. So 150 text should be fine. Yes. 150 text. Ah, let's say the duct size is 200, not the size, I'm least bothered about the size. Let's say the airflow rate is, say, for example, 5000 CFM. That's nothing but cubic feet of air that is having. So each color, let's say, I'm throwing some 500 CFM or so. So if I'm throwing this 500 CFM into this particular collar, now this duct cross section area, we will design according to your 500 CF, 5000 CFM. You agree? Because 5000 volume of air should go through this ducting. You agree? But this collar will be sized only for 500 CFM. Obviously, I don't require more. I'll design it for 500 CFM. But when you design it for only 500 CFM, the main disadvantage is now you could imagine it air flowing in this direction. So your airflow is going in this direction. Let's say this is your air molecule. Just a second. You've got multiple air molecules that are basically going in this direction. You agree? So your airflow will basically, from the blower fan, the air molecules will enter the plenum, then it gets diverted, and then it enters into your ducting. Yes or no? So when you have, see, how will the air flow? Don't you think it is because of the pressure differences? Because at this case, your blower fan is pushing the air in this direction, but this is atmospheric pressure. So compared to ducting, outside pressure is lower, which results in some air to go out. You agree or not?
Yes.
Hello? Right. So when some air goes into this, so out of this air, let's say the air molecule should come out. So when it comes out, do you think suddenly this guy can directly take a 90-degree
Yes.
turn? No, there should be some inertia, right? So for that inertia, to give space to that inertia, to use your effective volume will provide the shoe piece. That means airflow will go something like this and then it will enter. So that for that additional space is required for that basic inertia of air because it has to change its direction. Understood or not? What if you have not provided? If you don't provide, let's say your collar, you have designed it like this. So if you don't provide, what will happen? The air volume, whatever is going, the air volume, air, whatever is there, that particular air directly it can't take. So it will take like this. Because of that, there will be certain reduction in volume of air because you have size for 500, but certain volume is getting wasted because of the inertia. Am I clear?
Yes, it's here.
So for that reason, it's mandatory for us to give a collar piece for a shoe piece to a collar. Clear? So this is nothing but your collar piece. Then let's say I've given certain volume of air. So I've thrown over here and I've thrown over here. So 500 and 500. So if two 500s are gone, what is the remaining airflow rate? 4000 CFM. So don't you think for this 4000 CFM, I can reduce my duct size or not? Yes or no?
Yes. Yes. Yeah.
So I require only 4000 CFM, alva. So let's say this is 4000 CFM because already some have used. So in this case, what will we do? We'll connect it from here to here, and this is. Sorry, I'll keep my centerpiece common. So this is my reducer. Understood. Of course, need not be a center. You can have a single-sided reducer also. Basically, you're changing from one size of the duct to the other size of the duct. You can call it as a reducer. Understood or not?
Yeah.
So now let's say I have to throw it at this location. I have to throw it at this location. So what will I do? I'll basically have a, let's say, uh, just give an example. Let's say half of the air I have to throw it from here as well as here. So I have to deviate it like this. Sorry, I have to deviate it like this. Then I'll like fillet radius. Generally, all the radius what we keep it is 150 mm dia for the smooth airflow rate. And let's say this is my ducting. So what am I doing? Basically, I've shifted, I'm pushing the duct towards the right hand side. You agree? So now at the end points, you have to close the duct. Else what will happen? Instead of here, all the air will be dispersed over here. You agree? So for that reason, we have to close the duct. So that we call it as dummy pieces. And then what do? We basically provide some kind of collars. Let's say this is one collar, 2000 CFM means probably I have to go, I can go for some four number salva. Something like this. I can use one more reducer as well. Yeah. And similarly, I can even give it into this particular one. So if I want the duct inside, I can take an elbow over here. So like that, you will use multiple shapes of the duct according to your requirement. Understood or not? Am I clear?
Yeah. Understood.
So this is nothing but your duct components that we use it. Always remember this should be in the direction of the airflow rate. So like that, we always design your ducting entirely. Clear? Generally, after 500 CFM or 1000 CFM, we'll go for a reducer because every 200, 300 CFM, we don't do it because that will result in more number of joints. So every 500 or 1000 CFM, we basically try to reduce the number of joints. I mean, we'll try to do it. Clear? But again, it's not mandatory that for every 500 or 1000 also you have to do it. It's your comfort actually. So now what will happen? Whatever the air is flowing, that will pass through this ducting and then it will get connected through this airflow rate. It will enter into your room space. Am I clear? Hello.
Yeah.
Then
Yes, sir. Yes.
coming to the next one. So these are the components that you use. Then coming to the formulas for your rectangular ducting or different components. You can just make a note of it. These are the formulas that we use it. So 2L into W plus H. Anyway, while generating BOQ, will explain about this one. Taper is W1 plus H1 plus W2 plus H2 into ln, obviously. Elbow is L into W1 plus H1 plus W2 plus H2, where L is equal to W plus R. That also I'll explain you all these formulas. Don't worry. Dummy is width into height. Plenum is, it's a box section. So straight duct plus two dummies you have to add. You agree? Hello.
Yes, sir. Yes.
So, yeah, tell me. Sorry. So these are the basic formulas that we use to arrive at the ducting quantity always. Understood? You want me to apply this formulas now and explain you? Yeah,
Not
not
required.
required. Not required. Take it. Anyway, then while doing BOQ, that time I'll explain you anyway. Okay. So these are the formulas that we use it for calculating the surface area of all your attracted activities. And one more component, as I've told you, is mixing box. You remember? Whenever you connect a flexible duct, I've explained about mixing box, right? So this is nothing but your mixing box, where one side you'll connect your flexible duct, other side you'll connect to your air terminal. Am I clear? One side will be to your flexible duct for your ducting, and this will be for your air terminal. Got it?
Okay.
Then coming to the next one is you have your accessories like your flexible duct. I already explained about the flexible duct. Then you've got a volume control damper, fire damper. I'll explain about all these components, each and everything. So let's go further. Okay. So whenever you have this, whenever you do your ducting design, we have to install something called as a VCD, volume control damper, wherever there are some branches for air balancing, for ease of air balancing. Now here, whenever the air is flowing, it's okay in a straight path. Anyway, you can't do anything. But at this location, when 4000 CFM is, don't you think you have to ensure this as 2000 CFM and do this as 2000 CFM or not?
Mm.
But if I don't have any
Yes.
control mechanism, what will happen? Out of this, more air will flow through this because this is least resistance path. You agree? Straight up. But whereas elbow means air should change the direction. So because of that, what will happen? More will go. Probably this will go 3000 and this will only be 1000 C. You agree? So to remove
Mm.
the disparity or for ease of balancing the air, we'll install one more damper called as volume control damper, which will have a handle and it'll have blades. You can see it. It'll have a handle and it'll have blades. Okay, to this it'll have a handle or it will be motorized. This is an example of a motorized one. To this, you imagine one more right angle handle where you can actually change the lever. Understood or not?
Mm.
Yeah. So that one is nothing but your VCD. That is nothing but your volume control damper. Am I clear? So this particular handle, you can basically this particular handle, if you rotate it, these lower blades will change. So that will change the resultant friction factor. So what will you do in this particular one? This
Mm.
you'll increase it with some angle. This you keep it open so that you make sure that 2000 CFM and 2000 CFM is basically coming in the ducting system. Clear?
Yes, sir.
Is it done? I mean, you able to follow VCD volume control damper
Yeah,
or
yeah,
not?
yeah, yeah.
Okay.
Yeah.
So we have to place it at the branch, at this branch and this branch, we have to place your dampers. Yeah. Then coming to the next one is your fire damper. Okay. So this fire damper, you use it in locations where you want fire isolation to be done as per fire norms. I'll just give an example. Let's say here, instead of something like this, I wanted to throw air, let's say out of this 2000 CFM, some thousands, 1000 CFM have gone like this. And then let's say uh, the duct is going in this direction. I'm just giving an example. Let's say the duct is going in this direction for whatever reasons it is. Okay. So this duct you have used it, this duct you have used it. So now what will happen? Let's say this is the airflow rate you're going for. These are your collars that you have. But let's say this room is critical room where you have to do isolation of the fire. That means this particular room, this small rectangular room is there, no? Let's say this is a separate room wall I have got it, for which isolation is required. Let's say this is a battery room or anything. Let's say this is UPS room and this is battery room or the vice versa, whatever it is. So whenever there's a fire in batteries, do you want your entire room to be propagated or not? You want the fire to be propagated or not?
Mm.
You don't want it, right? So let the accident contain in that particular room at least for 2 hours, or like, as per the fine norm requirements anyway. Generally, like, 120 minutes will last. So if you say that, because the civil, it's a block work can definitely withstand fire,
Yes, yes.
or it has to be done with a fire rated gypsum, if not. And the door will also be fire door. It will not be normal, wooden shutter door or anything. It will just be a fire door, which can withstand 120 minutes, and we take test certificates also for that. But the weakest spot, don't you think, is your ducting? Because you have used ducting according to your width, say probably 24 gauge or anything. But can you guarantee that the duct can withstand fire? Obviously not. If there is a fire, it can
No.
easily melt away this one, and that will result in air from flowing from the smoke, or the fire couldn't go from this opening, which is above the ceiling, through this duct. Yes or no? Or if there's no ceiling, through the opening in the wall. You agree?
Yeah.
If there's a fire here, it can cut the duct, or even the smoke can escape through this. So for that reason, we use something called as this fire damper. So fire damper will be installed at this junction location where we use this particular element. The reason why you use this fire damper is you want to ensure that fire is not going through this particular duct. That means whenever there's a fire, this should shut this off. At the same time, it should withstand fire for 2 hours. You agree? Yes or no?
Yes, sir. Yes, yes.
So that's the reason you basically use. So for that reason, you basically use this particular fire damper. Am I clear? So when you use this particular fire damper, it will generally be around 16 gauge. We use it because that can only withstand. I mean, it should have a higher thickness. Okay, if it's a GI, generally we use GI only. We don't use aluminum also, because fire rating of aluminum is very poor. So you have to use GI, which is of higher gauge. There are two types. One option is automatically when there's a fire, the actuator will closes. So you integrate with fire alarm system, and whenever there is a fire, automatically the lowers will be closed. Understood? So that model you call it as fire damper with actuator. So generally it will be in open state, but whenever there is a fire, you will cut off the power. So because of the spring force, automatically these ducts, these dampers will get closed. Understood? But we use it nowadays to a larger extent. Second type that you have is one with a always be open with the help of a fuse. So you can see this particular one over here, the right hand side image. You can see this image or not? Yeah, you can see this bigger one.
Yeah.
Please respond, yes, sir. So here you can see
Yes,
a
yes,
kind
sir.
of a string over here. You can see a kind of a latch over here. You can see a kind of a latch over here. So this is a made of material like galvanum or anything, which can basically melt at 50 degrees or anything. So what will happen is this, you basically you have a spring loaded here. You will open this louvers and you will hook it to one of the louvers. So one of the louvers will have basically a small projection. It's not clearly visible here. So you will latch it to that gate. So when you latch it, what will happen? Because of this particular force of this particular fuse, it will be in open state, because this galvanum will be acting like a metal at higher temperature, and it will become liquid, sorry, at lower temperature, and at higher temperature it will snap off or it will cut. So because of the spring, I mean, it will oppose the spring force, it will hold tight together. But whenever there is a fire, that time this guy will basically snap off quickly. Understood? This guy will snap off. Understood or not?
Yes, yes, sir.
Yeah. So when this
Yeah.
snaps, what will happen?
It was.
Automatically it will get closed. So that is how this fire damper with fusible. So it doesn't require anything. Only thing is you have to replace it with the fuse. You have to get it whenever there's a fire accident. That's least of your concerns, right? Anyway. So when you don't have fire alarm system, or you think that like the maintenance is really poor, then you go for this fire damper with fusible link rather than fire damper with actuator. Clear? But fire damper with fusible link, the main problem is until the temperature raises to 50 or 55, it will not break. So smaller fires or smoke, if it is there, it will easily escape before this gets snapped. Actuator is the minute there's a fire alarm system, automatically it will cut off. Am I clear? So wherever you require some kind of fire isolation, you have to use these fire dampers. Am I clear or not?
Yes, sir. Yes. Yes, sir.
Okay. Then coming to the next one is the other accessories like your collar dampers, Figure dampers, pillbox, non-return damper, and a GAD system. So collar dampers. Where do we use collar dampers? For example, at this location, you have gone for VCDs. At these locations, you have gone for VCDs that I've already explained you. You remember? That is to control the volume of air. But whereas if you want to control the volume at the collar, for example, if you have generally supplied like this and at this terminal, let's say you've got a grill. Don't you think your first collar, can you give a guarantee of 500 CFM if you don't have any control device? If you just provide an opening in the starting, do you think only 500 CFM will come or more air will come or will flow?
More than.
More air will flow, obviously, because air will always choose least resistance part. So what should you do? You have to equate the resistance. So for that reason, you have to use one more damper called as collar damper. So you will introduce one more damper, which you basically called as collar damper. So at the terminal point, you will introduce one more damper, which you call it as collar damper. Am I clear or not? So for all collars, you will introduce one more damper, which is called as a collar damper. So it will be inserted in your collar in front of this integral, but still you can see a kind of a screw over here. So if you change this screw angle, then automatically this blade angles will also change. Am I clear? So that is nothing but your, this is nothing but your collar damper that we use it. Then coming to the next one is your Spigot damper. Spigot damper, you use it like a circular volume control damper or a collar damper, you get it. I've already explained you while explaining a duct over side. You remember? For a mixing box, when you connect, I told you you have a circular butterfly damper. Remember, if you have a straight duct, if you have a mixing box, you have a flexible duct. I told you, right? There's a circular duct. To this, you will have a damper again for ease of air balancing. And this will be connected through a flexible duct over here. And from here, air will flow. So at these locations, to control the volume of air per individual air terminal, you will go for this butterfly damper or the Spigot damper. You can call it as a butterfly damper or a Spigot damper. Am I clear? So that even connects between your main duct and your flexible duct as well. Got it? Hello.
Yes, sir. Yes, sir.
Okay. Then coming to mixing box or spill box, I already explained the use of mixing box or spill box. The main usage of mixing box or spill box is you want to ensure that the volume of air is from your main duct, the air will be pushed into that duct and from there it will flow into your terminal. So as I've explained earlier, from the side you'll connect the flexible duct, from the bottom you'll have your mixing box. From you'll have you connection to your air terminal so that from the side air will enter and from here the air will come down. I mean, it's shown in reverse fashion to show both the openings. Basically, it will be aligned in reverse fashion. The opening will be coming bottom towards the false ceiling. Understood? So you're clear of these two things? A Spigot damper and spill box. Spill box can also be called as mixing box.
Yes, sir.
Okay, then coming to the other component is your non-return damper. So your non-return damper is basically a component which is used in your editing. Now, you take an example of this one. Here, I didn't show you any NRD purposefully anyway. So now let's say this fan is running. Let's say this fan is in on state. This fan is in on state and this fan is in off state, let's say. One is in on and one is in off state. So when one particular fan is in on state, don't you think the air will flow through this guy? Something like this. So once the air comes over here, it will pressurize this plenum. Now, once air is present in this particular plenum, let's say this is your air molecule. You have multiple air molecules, obviously. So do you think this air molecules knows which direction should to go? So wherever there is a pressure difference, it will go off. Yes or no?
Yeah.
So now
Yes.
you have because this unit is off, so this fan is in off state. So don't you think here also you'll have atmospheric pressure? At this location also it will be
Yes.
atmospheric pressure or not? And here also it's atmospheric pressure. So don't you think some volume of air will try to enter through, come out again through to other unit or not? So some air molecules, don't you think it can come through this unit, it will come out? Yes or no?
Yes, sir. It will.
So that will cause two things. One thing is in your ducting, you will not have 5,000 CFM. So if the unit is 5,000, probably 3,000 will come over here, 2,000 air will short cycle. So your room will never get cooled because you're pumping less volume of air. Number one. Number two, your compressor or your control mechanism also will fail because the cold air is again directly coming over here. So it is not picking the heat from the system. So what will happen? The shut-off valve or the modulating valve or the compressor which is connected gets shuts off for this particular equipment. So for that reason, what should we do? We have to allow air volume only in one direction, but doesn't allow in other direction. That component you call it as NRD or non-return damper. Okay. So I'll just explain later. So you can just go for this equipment. So here, what do we do is at this location, we have a ducting at this location here. Just a sec. Here, we'll introduce something called as NRDs. This, we simply call it as NRD, non-return damper. So what does this NRD does is, non-return damper does is, this NRD will ensure that whenever the AH is on, that time this will be in open state, so that air will flow. Whenever the AH is in off state, then or so this is off alva. So whenever this is in off state, this will be in closed state. So when this is closed, let's say, and this is open, so this bottom one is open now. So I'm removing the hatch just to represent open, and the this one is closed. So if this is closed, can air enter through this second?
No. No.
No. So that is nothing but your NRD. There are two types of NRDs. One is gravity type, and the second one we call it as more this one with the actuator type. NRD with actuator, and other one is called as gravity type. So the gravity type of louver, how does it work is simple. Let's say this is your outer body. I'm drawing a section to understand. Okay. You've got hinges. I mean, from side to side, you have connected with hinges. And to that, you basically have your panel. You have your surface like this. Something like this. You have it something like this. Just a second. Yeah. You'll have something like this. So similarly, you have one more guy over here, something like this. Showing an example. Okay, you have it something like this. So that is your hinge. Okay. So whenever the air is flowing, it will be made of light material. Because of this hinge, this will rotate in this angle. This will open like this. And obviously the bottom one will open. Yeah. So air will flow when air is pushing in this direction. But in this direction, if it comes, because of this bevel angle, it will be in closed state. So automatically, when it comes, obviously it can't extend this guy, this duct here. You will have a small pin or anything, and because of the above pin, don't you think even this will also will not be able to close? So what will happen because of the gravity? We will use a gravity force to ensure that water, air doesn't flow in the reverse direction. So when air flows in this direction, this will get open. When air flows in this direction, it gets closed. Understood or not?
Yeah, correct. Yeah, correct.
So that is nothing but your NRD, non-return damper. Okay, you can see it. An example of this one is your NRDs on the right hand side bottom left side. This one is your NRD. Other one is simple, like your volume control damper only. You'll have an actuator. That's it. So you connect it electrically. So whenever the fan is open, you will open the bolts using actuator. So this guy is called as an actuator. You can see an orange piece over here, right? This is called as an actuator. Then this is also called as an actuator. So, like 5 damper with actuator only, it will also be. In 5 damper, what will happen? Whenever there is no fire, it will close. In this case, whenever the system is on, it will be on, else it will be in off state to remove the complications. Understood? So, I personally don't prefer gravity type because the gravity type will have rattling noise. Continuously, you'll get noise because it has to work against the gravity, right? So air will continuously hit, number one. Number two is there will be certain leakages as well because of the gravity type. Because it should free flowly. So you'll have certain gaps between the body and this blade. So because of that particular one, I generally don't prefer this kind of gravity type. I'll always prefer with actuator model, though it's a bit expensive. Understood?
Yeah, yes, sir.
Then coming to VAV, which will take a lot of time to explain. So tomorrow I'll again explain on VAV sound detonators and all these things. Or we'll park VAV aside because you have to okay, basic concept I'll explain you tomorrow, don't worry. But in-depth explanation I'll explain you once again because it has to be integrated with differential pressure transfer and VFD should also be there. So all those things I'll explain you. Types of VAVs, there are a lot of stuff in VAV. Then it will be about attenuators, crosstalk dampers, attenuators. Yeah. So anyway,
Right.
distribution theory itself will take 2 days for us. So one day is completed, almost half we have completed it. So remaining
Mm.
components we will discuss tomorrow. Is it fine?
Yes. Yes, sir. Yes.
Okay. So till now, you have got any queries, or I'm going fast, or it's fine. I mean, you guys are comfortable with this
Fine, sir.
pace.
It's fine.
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 Okay. Then tomorrow again we'll continue on the other components, which is your attenuators, other minor components are there, and then we'll directly understand about air terminals like grills, etc. Okay.
Okay.
So we'll wind up for today.
Okay. Yes, sir.
Okay. So I'll upload in the same YouTube channel, so you can view it afterwards. Okay. Fine.
Mm. Yes, sir.
Fine. Fine.
Bye, sir.